Okay, today we are going to be looking at page 11, 12, 13, and 14 in your packet. Let's first start with a little review. On page 11 says we are going to look at solving absolute value equations. And before I get into solving an absolute value equation, I just want a refresher as far as what is absolute value and what does it mean. Well, absolute value simply means the distance a number is from zero on the number line. So if I wanted to know the absolute value of the number 2, then you would tell me the absolute value of 2 is 2 because it is 2 places away from 0 on the number line. If I wanted the absolute value of the number -2, then you would tell me the absolute value of -2 is also 2 because it is simply asking how far is the distance a number is from 0. All right, so look at this statement here. If the absolute value equals 7, what are the possible values of x? In other words, if there is a number in my bars and I'm asking for the absolute value of it and I'm telling you that it's 7, then what could the number in here possibly be? Well, it could either be -7 or it could be +7 because both of them would give me 7. This time I'm asking what possible number would give me an absolute value of -4. Hopefully you know that it would be no number because absolute value cannot be negative. Absolute value will never be negative, it will always be positive. Absolute value is positive. So if it ever gives you a question and the absolute value bars are pointing to something that's negative, then you know that that's going to be no solution there. All right, now let's look at how to solve an absolute value equation. First thing we want to always do is isolate our absolute value expression. So that means we want the bars with the absolute value expression to be completely by themselves, nothing else on that side. For example, look at number 3. You have some bars here, nothing else is on that side. Now I know there's things inside, but I'm talking about on the outside. Here you have bars, there's nothing else on the outside. But look at number 5. You have absolute value bars, but there's something else on this side with it. That's what it means by isolated. You want to isolate the bars and get them by themselves. Then you want to set up 2 cases. We're going to set whatever's inside of our bars both to positive and the negative value of the number. And then we will solve both equations and check for extraneous solutions. That's a new word. What are extraneous solutions? They are solutions that do not work. And what that means is when you go back and you substitute your answer that you found back into your equation, it gives you something that's a false statement. So when you substitute your solutions and they don't work, it's an extraneous solution. And we always discard those. All right, so let's get at it. We're not going to do all the problems, but we'll just do a few of them together. Let's start first with number 3. I know I didn't circle that, so let me go ahead and circle that right now. We'll do number 3 first because the directions are for us to isolate our bars, and in this case, they are already isolated. So we're going to take what's inside our bars, our expression x minus 9, and we're going to set it equal to 2 different cases. We're going to set it equal to 5, but then we're going to take x minus 9 and also set it equal to -5. And now from here, all you have to do is solve each one. I'm going to add 9 here, and my x equals 14. And then I'm going to add my 9 here, and my x will equal 4. Before I circle those and say that those solutions are correct, I want to take these solutions and substitute them back into my original equation to make sure neither one of them is extraneous. Now, to do that, I need to look back at this here expression, x minus 9, that's in the absolute value bars, and I'm going to show you how to put it in your calculator. All right. So you want to go to your graphing calculator and press second and the number 0, and you see here that you've got ABS, well, it stands for absolute value, and then you're going to press enter. What we were checking to see were the solutions 14 and 4 extraneous. So inside the bars, it was x minus 9. Let me zoom in on that. So since we thought x was 14, we're just going to type in 14 minus 9. Since we got 5, that answer works. The other solution we picked, or we solved for and found, was 4. So this time, I'm going to come up here and copy this. I'm going to type in 4 minus 9. Notice I get 5 again. So since both of those solutions worked, then they are both going to be kept. Neither one of them is extraneous. My answers are going to be x equals both 4 and 14. It did not matter which one I wrote first. X equals 4 and 14. All right, let's look at number 5. Number 5 has not been isolated. So for this problem, you've got to first get the 17 over here. To do that, think about solving an equation. All we would have to do is subtract it. So I'm right, minus 17. Now my bars are isolated. I have y minus 1, and then on this side it's going to be equal to 16. All right, and now I need to set our y minus 1 equal to my two cases. I'm going to have y minus 1 equals 16, and y minus 1 equals a negative 16. Solve each one. I want to take both of my answers and substitute them to see if they are extraneous again. So go back to your graphing calculator and type second 0, and the expression, let me go back here and highlight it for you, was right here, y minus 1. We're going to use this one that's been already isolated. So that's going to give me 17 minus 1, which works. And now I want to get this again. And it's going to be, what was the other one? Negative 15. So I've got negative 15 minus 1. And it also works. This tells me that both of my solutions work. Neither one of them is extraneous. I'm going to write them down. My y equals 17 and negative 15, and the order that I write them down does not matter. All right, let's try one with a different step involved here. Now, whenever I ask my students how they think they're going to solve this, I always get students to say we're going to distribute the 3 into the bars. Well, that's not going to happen here, because if I want to isolate my bars, I want to get rid of the 3 that's multiplying it by dividing. So I'm going to divide by 3 on both sides. This will get rid of it. And now I have m plus 8 is equal to 13. Now that my absolute value expression has been isolated, I'm going to set them equal to two cases. So it's m plus 8 equals 13, and then m plus 8 equals negative 13. Solve each one. Once more, we want to substitute these answers into our expression, which is the absolute value of m plus 8. So I go back to my calculator, second zero, and my answers were 5 and negative 21. Let's do 5 first. 5 plus 8 gives me 13, as I hoped it would. And let's do the other one. It was negative 21. Both of them work. So my solutions for number 6 are 5 and negative 21. Number 7. Alright, so for number 7, once more, like number 6, you see that you have an equation that's not isolated. On this side, the bars are not alone. So I'm going to have to divide by 16. When you do so, you now have r minus 5 equal to a negative 2. Normally at this point, we would set it equal to two cases. But if you'll notice something this time, you have a negative number already here. Recall what I told you at the top of the notes. Your absolute value is never going to equal something that's negative, because absolute value is always positive. When this happens, your answer will be no solution. There's nothing we can do at this point. So instead of trying to set it equal to the two cases, if the number's already negative there, then that's going to be no solution, because absolute value is always positive. Absolute value is always positive. So that's a trick question. Number 8. Notice you'll see that your absolute value expression is being divided by negative 2. So for us to solve, we need to multiply by negative 2. Multiplying by negative 2 on this side cancels this out. And then by multiplying by negative 2 on this side, I get 12. So now I have y minus 10 in the bars isolated equals to 12. Set your two cases. Y minus 10 equals 12. And then y minus 10 equals negative 12. Solve each one. And check your solutions. Second zero, and go back. What was my expression? It was y minus 10 in the absolute value bars. So I'm going to type 22 minus 10. Gives me 12, as I was hoping. And then let's do second zero again. And the other answer was negative 2, so I've got negative 2 minus 10 as well. Both of them work. And I know at this point right now it seems like every answer is working, but there will be a time when one of your solutions or both of your solutions may not work. All right, so now that I know these do work, I'm going to write that y equals -2 and it equals 22. All right, let's just do a few on the back. All right, let's start with number 12. Whenever there's a problem with a fraction involved, sometimes it gets us a little confused. So let's start with number 12. We still want to isolate this absolute value expression here. So I got to move the 8 over and I got to get rid of the -12. So let's think about this. If this is +8, then I'm going to have to say -8 to cancel it out. When I do that, I'm going to get -24 on this side. And then I need to bring down my -12, and this is going to be multiplied by the k divided by 5 in the bars. At this point, I see that these are multiplying, so if I want to undo the multiplying, I got to divide by -12. That will give me a +2, cancels this out, and I've got k over 5 equals +2. That means I'm going to write two different cases. I'm going to have k over 5 equals +2, and I'm going to have k over 5 equals -2. This is pretty simple. I just have to multiply here. So I would have 5 on both sides multiplied, which would give me k equals +10. And on this side, when I multiply by 5, I'm going to get k equals a -10. From this point, I would substitute these values in back to this expression, k divided by 5, and see if I got a +2. To save a little time, I'm just going to go ahead and let you know it does work. Okay, so those two solutions, 10 and -10, will work once they are checked. Okay. Now let's get to one that has variables on both sides. When you look at number 13, immediately you should see that there's an x on this side and there's an x on this side. But what we've got to concern ourselves with is, first, are my bars isolated? And they are. There's nothing else on this side with 3x minus 9 on either side of the absolute value bars. So I may proceed with my two cases. In my first case, I'm going to leave it positive. So I will have 3x minus 9 equals x plus 1. And on my second case, I'm going to have 3x minus 9. But this time, I'm going to change both of my signs, and it will be -x minus 1. Now, just simply solve both sides. Here, I'm subtracting my x. Add my 9. Divide by 2. On this side, I'm going to add my x. Add my 9. Divide by 4. Now when we check for our extraneous solutions, we're going to take them one at a time again. But we're going to have to substitute the x here and here, and make sure that both of the numbers we get on both sides are the same. So let's do that. Start first with the, where did the problem go? 3x minus 9 in the absolute value bars. And it was 3 times 5 minus 9, and I got 6. Okay, now I need to put that same 5 here, and it'll be 5 plus 1. Since when I put this 5 here, I got 6, and when I put it here, I got 6, well, that's the same number. 6 equals 6, so that answer works. Now I need to do, oops, having trouble right here. Now I need to do this side right here. Okay. On this side, I have the solution 2. So I'm going to go back to my absolute value bars, and that's second 0. 3 times 2 minus 9 is 3. And then go back to the problem here. I'm going to put 2 plus 1. And I got 3. So that tells me that both of my solutions are going to work. All right, both of them work. My answer is 2 and 5. Last problem. All right, so for number 14, you have your absolute value expression, and it's not isolated because it's being multiplied by 2 here. So if it's multiplied by 2, I'm going to need to divide by 2 on both sides. I'm dividing by, oh, that's so crooked. Hold on, let me fix that. I'm dividing by 2 here, and this cancels out. And I divide by 2 here, and that's going to give me 7h. So on this side, I have h plus 8 equals 7h. And now I'm going to set up my two cases. My first case will be h plus 8 equals 7h. And then it'll be h plus 8 equals negative 7h. From here, I just need to solve. So I'm going to subtract my h. And 8 is going to equal 6h. Divide by the 6. Going to get a fractional answer here. 4/3. And on this one, same thing. I want to subtract my h again. I'm going to get 8 equals negative 8h. Divide. And this time, my h equals negative 1. All right, so now I'm going to substitute this back into my expression here. And let's start with, there it is, 4/3. Second 0, and it was 4/3 plus 8. That's what it gives me. And then I need to put 7 times 4/3. And it works. So I know this solution works. It checks out. Let's try negative 1. Go back to my absolute value. And it was negative 1 plus 8. And then on the other side, it was 7 times negative 1. There you go, our first extraneous solution. When you substituted the negative 1 back into both sides, on this side it gave me 7, but when the negative 1 was substituted here, it gave me a negative 7. That tells me that the solution of negative 1 is extraneous. So that means my only answer would be 4/3 for this problem.